Assalamualaikum. My name is Nur Suhaila binti Ismail. In this video, I will show you on how to explore clustering in WEKA. Basically, WEKA contains clusterer for finding groups of similar instances in a dataset. Clustering schemes available in WEKA are K-means, EM, COP-WEK, X-means, and factors first. But in this video, I will show you on how to use K-means. Firstly, we need to load iris dataset. In clustering, we need to remove class attribute. There are two ways on how to remove the class attribute. First way on how to remove the class attribute is by just clicking the class attribute and select remove. Then go to the cluster tab, click choose and select simple K-means. Click here and set the number of cluster to 3 because we have 3 classes, which is iris versicolor, iris virginica and iris setosa. And then click OK and then click start. This is the first way on how to remove the class attribute. The next is I will show you the second way on how to remove the class attribute. The second way is you can just go to the cluster tab and then select simple K-means. Make sure the number of cluster is 3 and click ignore attributes and select the class attribute to remove the class attribute and click start. The way WEKA evaluates the clusters depend on cluster mode. There are 4 different cluster modes are available in WEKA. In this video, I will show you 2 differences of the cluster mode, which is by using use training set and by using classes to cluster evaluation. I already show you by using use training set mode, and the next is I will show you by using classes to cluster evaluation. First, select the classes to cluster evaluation. Select to remove the class attribute and select start. The difference between use training set mode and classes to cluster evaluation is in the use training set mode, we can see that there are cluster 0, 1 and 2, but it does not show that cluster 0 refer to what class, cluster 1 refer to what class and cluster 2 refer to what class. But with the classes to cluster evaluation mode, it shows us that cluster 0 refer to iris versicolor, cluster 1 refer to iris setosa, and cluster 2 refer to iris virginica. And the rest is the output is same. The only difference is classes to cluster evaluation display the name of the cluster. This is the output of the clustering in WEKA. but I have summarized it to give you more understanding about it. Okay, first in Weka, we have 5 attributes, which is sepal length, sepal width, petal length, petal width, and class. But we ignore the class attribute, and the instance of the iris dataset is 150. This is also the output of the clustering, and we can see that this is within cluster sum of square errors is calculated, which is 6.99, and then the clustering model shows the centroid of each cluster. Cluster centroids are the mean vectors for each cluster. So each dimension value and the centroid represents the mean value for that dimension in the cluster. The centroid can be used to characterize the clusters. Weka generated clusters are cluster 0, 1 and 2. Cluster 0 shows that this is a segment of cases representing sepal length, sepal width, petal length and petal width. And cluster 1, in cluster 1 there are 5.006 of sepal length, 3.418 of sepal width, and 1.464 of petal length and 0.244 of petal width. And in cluster 2, the mean shows that there are 6.8462 of sepal length, 3.0821 of sepal width, 5.7026 of petal length and 2.0795 of petal width. This is the output of the cluster instance. In the cluster instance section shows the number of instances in each new cluster. For example, in cluster 0 we have 61 instances, in cluster 1 we have 50 instances, and in cluster 2 we have 39 instances. Lastly, the output of the clustering shows that the classes to clusters represent class attribute which is assigned to cluster, and the last line displays to you 17 number incorrectly classified instance, which is 11.3%. One other interesting way to examine the data is to inspect it visually. You can right click and select visualize cluster assignments. Okay, in this visualization, you can choose what axis do you want. For example, I select the cluster and I remain the y-axis to sepal length, and the color of the class is class, and then the output is here. We can see that you can see the result in a visual rendering of the relationship within each cluster. For example, you can note that in cluster 0 we have 6.1 of the sepal length, and it refers to iris versicolor. For example, if we click here, it shows that the sepal length is 6.1 and it refers to iris versicolor. It will display all the info of instance which is in sepal length of 6.1. And you can also see that it also displays the value of the sepal width, petal length, petal width, and the class and the cluster. Same goes as in cluster 1, which is example in cluster 1 is 4.3 value of sepal length, refer to iris setosa because the color is blue. For example, if we click it, we can see that there is only one instance that display the value of that have the value of sepal length 4.3, which is the instance is located in number of 14, and it also display the sepal width, petal length, petal width, the class, and also the cluster. Same for cluster 2. For example, if I click here, it tells that the sepal length value is 7.7 and the class is Iris virginica and the cluster is 2. This info display all instances that have the sepal length value is 7.7. If you want to save the result, you can just click save button in the visualization window, and you can put any names and you can save it. Next is explanation about clustering but with hierarchical agglomerative.
In cluster, choose hierarchical cluster. For the distance function, choose Euclidean distance. At the ligand type, choose single. For the num cluster, has 3 classes. Okay. For the ignore attribute class, and start. Has 5 attributes: sepal length, sepal width, petal length, petal width. Ignore class. Cluster 0, Iris sentosa. Cluster 1, no class. Cluster 2, Iris versicolor. Incorrectly clustered instances, 51 data, equal to 34%. This is the visualization of diagram of single link of Euclidean distance. Now, change the ligand type to complete. Okay. Start. Attribute also have 5. Inno class, cluster 0, Iris sentosa. Cluster 1, Iris versicolor. Cluster 2, Iris virginica. Incorrectly clustered instance, 18 data, equal to 12%. is the visualization of the diagram of complete length of Euclidean distance. After that, change the linker type to average. Start. Cluster 0, iris setosa. Cluster 1, iris versicolor. Cluster 2, iris virginica. Incorrectly cluster instance 17 data equal to 11.33%. This is the visualization of the diagram of average length of Euclidean distance. We can see the differences of the diagram between the single link, complete link and average link. Now change the distance function to Manhattan distance. Link type to the single. Okay. And start. Cluster 0, iris sentosa. Cluster 1, iris versicolor. Cluster 2, iris virginica. Incorrectly cluster instances 48 data equal to 32%. This is the visualization of the diagram of single lane of Manhattan distance. In the Manhattan distance also, change the link type to complete. Okay. Cluster 0, iris setosa. Cluster 1, iris virginica. Cluster 2, iris versicolor. Incorrectly cluster instances 24 data equal to 16%. This is the visualization of the diagram of complete length of Manhattan distance. Lastly, change the link type to average. Cluster 0, iris setosa. Cluster 1, iris virginica. Cluster 2, iris versicolor. Incorrectly cluster instances 16 data equal to 10.67%. This is the visualization of the diagram of average length of Manhattan distance. We can see the differences of the diagram of single link, complete link and average link in Manhattan distance.